How's everyone doing? Excellent. Good to hear. Thank you for having me here today. It was a bit of a rush, which is why I'm a bit hot and sweaty, but it's good. We've got some good stuff to get through. Bit about me, but you don't really care about that. I work for ThoughtWorks. You might have heard them, software consultancy, so I work as a developer, and I just go around to different clients, helping them build software and solve their problems across a range of tech and so on, some of which is serverless. So I have to call it out, although I am a dirty consultant, like I have no ties to any of this tech here. I'm not trying to sell you anything. I will be honest in my appraisals of it. Use it, don't use it. It's totally up to you. Okay, so this is our little agenda for today. So we're going to cover what is a serverless architecture, just so we have the definitions in our heads. We're going to then get on to some of the more interesting stuff. This is Tales from a World Without Servers. So telling you about a project we used serverless stuff on, how it went, what was good, what was bad, what we would do if we did it again. That's the kind of stuff I want to get across that hopefully you could take that on board when you maybe start using this in the future. And the last one, should you use a serverless architecture? Why bother? What are the trade-offs? So what is a serverless architecture? So first of all, I think we all have to agree it's a terrible name. Serverless, what does that mean? So can we run software now without physical machines? Of course not. But unfortunately, like I thought the marketing people had got hold and it was too late. But now, some of you might have seen there's been this Jeff renaming. People have renamed it as Jeff because they're like, let's just give it a name that doesn't imply anything. So there's now like Jeff Conf and stuff where you can go and find out about the technology formerly known as serverless. But anyway, so it's an annoying name. So let's look at a definition. And sorry, this is as wordy as it gets. So we're home free from now on in. So what are serverless architectures? Internet-based systems where the application development does not use the usual server process. Instead, they rely solely on a combination of third-party services, client-side logic, and service-hosted remote procedure calls. Because I only want to say that once, we'll call them functions as a service from now on, which seems to be quite a standardized term. So kind of let's dig into some of those terms. So the first one, Internet-based systems, the application development does not use the usual server process. What does that really mean? It means that we are running software on servers that we don't own. Be that own in a data center or own in a cloud service that we've spun up. Even if you spin up an EC2 instance, you still have some ownership of it and you have to take care of maintaining it and installing software on it and so on. So I'm just getting me notes. What are the benefits of that? Well, straight away, you don't have to worry about installing software on it. You can't log into it even if you wanted to, which you could see as a downside, but actually, as we'll see as we transpires, has some upsides. You don't have to worry about servers randomly going down or rebooting or hard drives getting messed up. You don't have snowflake servers where they're kind of critical to your business, but you kind of don't really know what's installed on them. But you've got to keep them around because they work. We've all been there. So even if you use good practices like infrastructure as code and use stuff like Chef or whatever to make sure you can provision your servers to a known state, that's still extra code you have to write and maintain as a team, and there is, that is debt you are taking forward. Even if it does what it needs to, you've still got extra complexity in maintaining all that stuff. That's kind of the usual server process. It then talks about third-party services. So what do we mean by that? That's simply things like cloud databases, like maybe using an AWS-hosted Elasticsearch cluster or Google Firebase or one of the Azure, let's say Azure SQL or something like that. You're basically saying, hey, I need a database, but I don't want to have to care about managing the failover and the backup and the clustering. I'm just going to outsource that to someone else, and they're going to run it for me. And that same logic you can apply to things like authentication systems, so using something like Auth0 or AWS Cognito services. Again, you're saying, hey, I don't really care about this stuff. It's critical to my service or my system, but I don't want to have to care with running it. It's kind of just the glue that holds everything together, so I'm just going to pay someone else to handle that for me. And so you'll pay a third-party service, and they'll run it, and you'll just kind of connect to it. So you're kind of outsourcing that capability. We then talk about client-side logic. That's simply about shifting your logic towards kind of, I guess, more thick clients, things like single-page applications, mobile apps and things like that. But now we get onto the most exciting bit, which is these service-hosted remote procedure calls, so functions as a service. So confusingly, the term serverless has already come to mean at least two things. The first is this kind of whole definition, but serverless also has now come to refer to just these functions as a service bits, which makes it doubly confusing. But this is what we're going to stick to really for the most of the talk, because the functions as a service present much newer ways of how we think about technology, how we build our systems, and have been driving quite a lot of the hype. So we're going to focus on those mainly. So this is just an illustration of the previous slides. So traditionally before, this kind of yellowish blob is our server. Whether it's one we own on-premise or in the cloud, it's a server. And we had on it before a bit of logic, some auth, another bit of logic in a database. And we'd have a client. In this case, it's something that looks like a browser connecting to it. That was fine. Maybe they didn't all run on the same server, but it was on some servers that we took care of. And now, moving to a serverless model, you shifted some of that logic up to the client, and you're connecting to other hosted services that you aren't responsible for kind of maintaining. So maybe an auth one, you've split up your logic into these functions as a service, which we'll get into, and you've got a hosted database there. So it's just another way of visualizing it. So what are these functions as a service things that we're mentioning about? So there's some key properties to them. So the first, independent server-side logic functions. So it's a bit of a long one. Basically, these functions don't have to rely on each other. They can be deployed independently and run independently. They're server-side, fair enough. And the logic functions, they are just the same as the functions you write in your code every day, whatever language you use. Functions, you have some input parameters, you do some processing. There might be some side effects, but then you have some output. Nothing more, nothing less. And we've got a few little code examples coming up so you can just see them, but nothing more. It's nothing more fancy than that. Stateless is a key property. So underneath the surface, you have no control over what servers these run on. So therefore, you have no guarantees that anything you put on a server that you run your function on will be there the second time. So they are stateless, and you have to treat them as such. Some of them give you access to a temp folder, but you should only use that for doing kind of midway calculations. You can't rely on that temp folder being there the next time. They're ephemeral, basically means short-lived. These functions designed to spin up, do a job, and then shut down again. They're not meant to live that long. Event-triggered is a key property. You can call these functions directly using some cloud APIs, but the idea is that they will be triggered from something else happening in your world, in your kind of cloud-hosted world. We've got some examples coming up, but for example, an incoming HTTP request will trigger a function to do the processing of that request. Scalable by default. So this takes advantage of some of the previous properties, the ephemeral nature of them, the statelessness, and basically will say, I will run as many functions as you need to process all the input that's coming in. So however many events are coming in, I will trigger as many functions need to be run. So that's quite a key property. And the last one, it's worth calling out explicitly, they're fully managed by a third party. So basically you're saying, paid cloud provider, be it AWS or Azure or Auth0 or Google Cloud, they all offer functions as a service in some form. You're saying, hey, I've got this blob of code here, my function, I'm going to give you that. And I want you to, and this is how you trigger it, and just trigger it as many times as you need to. And it will take care of storing that code and calling it on demand. So you've stripped away all the other stuff in your application. You're just giving it like the bare bones logic, and you're giving that to the cloud provider to run whenever you require it to be run. So I kind of like to think of functions as a service as kind of the next evolution of cloud-hosted software. So in these diagrams, you've kind of got this cloud, but then the green line down the middle, anything to the left of that green line is something you have responsible for the uptime and maintenance of. So top left, we've got our kind of traditional infrastructure as a service offering, where we're responsible for the server. So an EC2 instance, let's say, sure, we can spin one up whenever we need, but we're still responsible for putting stuff on it and keeping it around and spinning up a new one if it goes away and stuff like that. We then build an application, whatever it is, I don't know, a Ruby on Rails app or something like that. But we build that application, so we're responsible for that. And that application is made up of many functions. And we have to take care of moving that application, putting it on the server. Sure. Then we get to here, which is more your, something like Heroku, something like that. or some of the other cloud offerings, maybe Elastic Beanstalk or something like that, where you're saying, hey, I don't actually care about the server. I still want to build my application. I still want to build my Ruby on Rails app, and I want to give it to the cloud provider and say, hey, run this for me, please. I don't care which server it runs on. Maybe you have to set some options to say how powerful you want that server to be. Like in Heroku, you select the number of dynos, I think it is, whatever. But you basically say, hey, run this application. I don't care about how it runs under the covers. Just do it for me. And you're outsourcing that capability. And that's cool. And in a way, you could maybe think of containers as kind of like this as well. You know, you're chucking up your container, which is your app, but you're saying, I don't care about the underlying infrastructure. And then the next evolution is functions as a service, where here you're not even building an application. So you have no Ruby on Rails app. You just have a series of discrete functions, and you're giving them to the cloud provider. So you're not even saying, don't even have the kind of boilerplate code around those functions. So there are trade-offs with that, but this is the kind of next model. So when it says evolution, I'm not necessarily inferring that the next stage is better than the previous one. You're just moving a couple of sliders further over, one in terms of how much you're delegating to your cloud provider to handle for you, and in terms of also the size of the deployable units. We've kind of got down to servers, to an application, to actual just individual functions. So let's have a little look at a code example. This is a super simple AWS Lambda code example written in JavaScript. This runs on their Node runtime. So this adds two numbers together. So you have a function which takes two parameters. One is the incoming event, and the other is some context. That interface is set. That's what you get. You can't change that. So you have to adhere to that interface. So the event parameter gives you your input data. That will change based on what's triggered this. This makes no inferences about how it got triggered. But it basically has two properties on it, one called number1, one called number2. We do a console.log on line 2 to say we started. We do some validation. And then that context object actually has some callback functions on it that we call for when we're done. There's a context.fail, so if something goes wrong, we call that. And there's a context.succeed, and we can pass in the result. And that's kind of it. This is as simple as they come. Context also has some other properties like what the name of your function is, how much memory it's been allocated, stuff like that. So you get a bit more information about your current run of the function. But this is all it does, and this is the same thing in C#. So it's a bit more wordy because you've got to do some deserialization, but it's basically the same thing. And again, this you have to adhere to the interface that it gives you. This makes use of a NuGet package, amazon.lambda.core. So this runs on .NET Core, but it's the same thing. So I mean, under the covers, Amazon runs, or AWS Lambda, which I'm going to talk about most of the time just because that's the one I have experience with. So I can't talk to Azure Web Functions and things like that. I've heard about them. They sound cool. Similar kind of concept, but I can't really talk about them, so I'm not going to claim to. But Lambda, under the covers, is running on Amazon Linux. So anything that runs on Linux, you can basically use for your functions. It comes with out of the box for support for, I think it's Java, Python, .NET Core, JavaScript, Golang now as well. Cool. And basically, is something else? Oh, PHP as well, cool. But the joy is anything that runs on Linux, you can just wrap it. You can run shell scripts on there if you want. You can just wrap it. So before Golang became officially supported, then I've seen people use it just by running the JavaScript one and just shelling out and running your executable in there because it's just running on Linux. And so kind of the world is your oyster. So you choose your runtime, give it your function, and it'll run it for you, basically. So it talked about the event sources. So there are a myriad of event sources. These are just a few of the more common ones. So this is basically what triggers your function to be run. So again, this is in the AWS world. Similar things will apply in other cloud providers. So DynamoDB, so AWS is one of their database offerings. You could set it up to basically act like a database trigger. So you say, hey, if a new row lands in my DynamoDB table, trigger a Lambda function to process that data, and then do whatever you want with it. Or if a row gets updated, whatever, you've got these hooks that you hook it into. S3, you could say, hey, if a file drops into my S3 bucket, trigger this Lambda function. This is a typical example I've seen of Lambdas is doing some kind of image processing, let's say for creating thumbnails or some filtering. You watch an S3 bucket for the image to drop in, you call out to the Lambda function fires automatically, does the image manipulation and then pops another file back into a different bucket, something like that. SNS, so picking up notifications from however your system is doing it, but text messages, whatever. API gateway is a big one, so I mentioned earlier about processing HTTP requests. So API gateway is Amazon's service for spinning up very scalable HTTP endpoints, basically, to have kind of nice RESTful services and things like that. So you were basically, you could have your API gateway here, and you say, hey, if this specific endpoint gets hit, actually fire up a Lambda to do the request processing, and you'll pass let's say it came in as JSON, you would pass the JSON body into the Lambda function, it would grab it, do whatever it needs to do with it. And a scheduled event, you can basically use Lambda functions as fancy cron jobs if you want, and just running them every 2 hours, whatever. The joy of that is that we'll get onto cost in a bit, but I've run systems before where I've had machines just sitting around waiting to run their cron job, just accumulating cost and waiting to break. Well, here you just pay for however much it uses. So that's pretty cool. So there's loads more, and it keeps getting added to every day. Basically, every other service will be able to hook events in. But I like to kind of think of Lambda functions. They're the kind of glue that glues together all the other services, which is quite nice. So anyway, we've got over that. Right, Tales from a World Without Servers. So in the background here, underneath the green fade, is a team that I was on, my lovely team, wearing our Friday stripes. I think it's very important when you work on serverless systems that you all wear stripes on Fridays. This is a key takeaway. We worked for a client that was in the events business. And when I say events, kind of like Excel Centre style events. So like London Book Fair, maybe some business-to-business ones, Sheet Metal Expo 2016, things like that, ones you've never heard of that are massive. But they ran these big events, and they had built all this software around their events that needed to run the website for the events and do registrations and allow people to see who was exhibiting and arrange meetups, because it's all about networking, all that stuff. So they built all this software. They didn't really know who was using the software, how they were using it, and so they didn't know what to build next or what software, what was the highest priority. It was basically who shouted loudest. So they said, right, can you just come in and build some kind of dashboards that slurp data out of all of our systems that we've got and present it to our business users in a way that they can use it to make smart decisions about what they do next and what they need to improve. So we thought that makes sense. So this is the kind of user-facing bit. This doesn't matter at all about serverless, but I just wanted to show you this because it's the bit that was presented to users, so the reason for having the underlying serverless tech. So this was actually Microsoft Power BI, and what it shows doesn't really matter. I think it's showing visitor retention flow for registration for one event or something like that, but this is what we built. So I'm not going into too much detail, but I'm just going to kind of briefly describe the architecture of our system, just not as this is how you have to do it, just as this is an example of a serverless architecture that worked for us. And it's not particularly complicated, but I think that in itself makes it a good candidate. So the client had all these different systems sitting around that had some APIs, but some stuff was sitting in files on disks and things like that. So what we did, we had a few Lambda functions. The first on the left, we had a producer Lambda, we called it, which is basically, as I mentioned before, a fancy cron job would just spin up on a regular basis, hit some APIs and work out what work needed to be done. It would then pop some kind of work to be done on Amazon SQSQ, and a bit of metadata in a DynamoDB entry, and then some worker Lambdas would spin up, pluck things off the queue, and start processing data, pulling things out of the APIs, merging things together. It's a bit of a little processing system. And then when it had done that, the Lambda would fire data into this metrics API service, which is here. So this metrics API service is, from the outside, basically just in a series of HTTP endpoints that you could use to store event data. So we built it this way, separated it out, so other teams who didn't need us to build the collection bit could just start firing data straight into this as soon as we built it. So we actually built this bit first. But it consisted of API gateway, which I mentioned before, so we had a few endpoints, like one to take a single metric, one to take a collection of metrics. And then had as you'd hit an endpoint in API gateway, it would fire off a Lambda function to process that request. So wasn't doing much, just doing some basic validation with the key fields there. It would add a bit of metadata, like what time it got ingested, not what server it was running on, but some other data around that, just so we had some kind of like logging and metrics. And then it would push that into a hosted Elasticsearch cluster on AWS, which is our data store, and then the BI tool just sat above that and hooked the data from Elasticsearch. So they conceptually two services, although because they were made up of individual functions, they weren't deployed as a living app, but we thought of them conceptually as two services. We can get on to deployments shortly. So this was kind of the underlying system. So let's talk about what we liked about the serverless tech that we used and what we didn't. So I mentioned earlier that scalable by default, and it's true. It really is pretty awesome. As many Lambda functions as you need are spun up and ran, so it will always attempt to meet the needs of the incoming events, which was great. So straight out the box, we had a scalable API that was as powerful as it needed to be. This is kind of like the main difference from platform as a service, in that often with platform as a service like Heroku, as I mentioned earlier, you kind of deploy your app, but then you move a slider for how powerful you want it to be, how many dynos you want. In Lambda and serverless architecture, well, there's not really a slider. You just have everything or nothing. There is generally no slider to constrain it. And the scaling is instant as well. Is in instant compared to the more traditional ways of doing things. So what you'd have normally, let's say in infrastructure as a service world, you'd probably have a load balancer and then some auto-scaling group underneath that would monitor some metric, I don't know, CPU, incoming request levels, and if some trigger got hit, it would spin up another instance, join it into the pool, put it under the load balancer so you can service more traffic, and when the load goes down, it would happen in reverse and take it off. And that's cool, and you need that to scale systems, but that isn't instant because depending on what operating system you've run, you've got to spin up a new server, it's got to join into the load balancer has to validate that it's healthy, and similarly going away again, so your demand could have gone right up and you're still slowly adding things in, but similarly when the demand goes down, it'll take you a while to take them off, and then you're accruing costs for servers that aren't doing anything. Whereas this, your functions are so small, it just fires as many as they need to do. There's a bit of a cold start if it happens to land on a new server underlying, but compared to spinning up new servers, it's really not much at all. We didn't experience any problems there. So that's quite a big difference and can be crucial if your system needs to be really responsive in terms of if the traffic's really spiky and things like that. And API Gateway also scales very well. So the two of those together, straight away, you get a really scalable API, which is pretty great. However, there are, as we found, hard limits. So Lambda does have throttling levels in place. So I think by default, let me check, you get 100 concurrent executions of your function at a time. And if the 101st comes in, it won't run it. That sounds really bad, but actually what Amazon, they put that in place, as we learned, for your own safety, because they realize it can scale infinitely. So they just put that limit in to make sure you know what you're doing. So when you hit it, you can be like, yes, this definitely makes sense, and I'm not accidentally, writing a botnet or something like that, getting yourself in trouble. And then you can just apply to them to say, hey, please, can you take off the lock, and they'll do it, and then you can have as many as you want. So just worth bearing in mind that is there. The other thing that's slightly negative is that you can't constrain the scalability. So if you remember back to the architecture, we were hitting some APIs on the client system. So our application was happily spinning up and just starting to fire loads of traffic at them. And these systems could not handle it. So we basically kind of created our own denial of service attack on the systems we were trying to get the data out of, which is why we had to partly implement a queuing system to actually kind of lower back the traffic. There was no other way of constraining it. So that was interesting. So just bear in mind that everything else needs to be able to keep up with what you're doing with Lambda, because that won't probably be the bottlenecks. You're just going to push that bottleneck somewhere else. So cost. So most of us are developers, so we don't care about that stuff, but there are two managers here. So for them, we'll talk about cost. But also, this is a really good lever for getting serverless into one of your systems or trying out, selling people on the cost benefits of it. So, I mean, the headlines are you basically only pay for your function throughput. So if your function runs for a second, you pay for 1 second, and that is it. It's actually a function of memory multiplied by the runtime. So you say up front how much memory your function needs, and you pay for the multiple of those two, and then it works out the cost from there. But it bills to like the nearest 100 milliseconds. You can tell that the fact they're going to that level of granularity, they expect these functions to be quite short-lived. So compare that to a normal application where you pay for your servers regardless of how much traffic they're processing. If you're spinning up 10 servers, then you pay for those 10 servers. So even if you're trying to be smart and you're thinking, well, we need to have enough in place because we know we get this uptick around 6 p.m. each day in our service, so we need to make sure we have enough laying around. They're going to be dormant before then, and so you're always going to be trying to do fancy things to save money or get them in the right place at the right time. And this, you don't have to worry about it, you just pay for the time they use, which is pretty good. And just as an example of some of the costs, so if you've got 30 million requests that use 128 meg of memory each, and they're running for 200 milliseconds, so that could be that's reasonable numbers for a quick, HTTP endpoint. That's going to cost you like £10 for 30 million requests, so the numbers are kind of ridiculous. And even on like the free tier of AWS, you get 1 million free Lambda runs per month. So you could probably use that for a bunch of, side projects or prototypes and things like that without even accruing any cost. So there's an online price calculator, as with all Amazon things, to see how much they cost. So this is really cool for scheduled jobs that I talked about, because you literally only pay for the time that it's running, which is great. Anything with surging traffic profiles, spiky traffic, works out great, especially if you don't know what that traffic is going to be. You can kind of hedge your bets, and you're not going to probably get screwed on the prices. I'm not saying this is cheaper in all circumstances. If you really know your traffic profile, you could probably, and I've seen it happen, you can have, if you take more of the responsibility of your app in-house, you can probably optimize to make things cheaper. But if you're going into a new world, or you just don't want to have to worry about it, it makes it a good candidate. It's also worth bearing in mind that those numbers I was talking about are just for the running of the functions. It's very rare that a function will just run in isolation, because then it won't have affected anything. You're going to have to pay costs for any transfer fees for moving data around any other Amazon services or other cloud services. They will have their own costs and will typically be higher than this, so any data storage and stuff like that. So hopefully it's obvious, but it's just worth calling out. So testability. We're developers, we care about testability. How does that work with this kind of new paradigm of development? So local unit testing is brilliant, because if you remember back to the code examples, you just had a function, and functions are pretty easy to test, especially ones that always have the same entry parameters and behave in pretty much the same way. So all your tests look very similar, which is really nice, so you can reuse a lot of your kind of testing setup. And because it's forcing you to write small levels of deployable functions, your tests are really quite well scoped, and you don't end up typically with these kind of monolithic tests that test loads of things at once, because it's forcing you down the path of smaller units already, which is pretty great. So you can test drive these things out really nicely. And because the functions are just written in whatever your language you've picked, you can just use all those testing tools that come with that language, and that's fine. So for kind of like the TDD side and local dev, brilliant. What gets a bit more interesting is when you're trying to treat it as you move up to the next level up, and you're dealing with kind of maybe, let's say, service level tests. So as an example, let's say we built you built a Node.js web app that had some endpoints on it, and you wanted to hit those endpoints and fire some HTTP traffic at it and check what comes out the other end. So treat it more as like a black box. You've done your internal testing, but you want to hit some traffic and check what comes out the other end. Fine, you could do that locally. You could use whatever lovely services you've got, build that into your local test run thing in your CI, lovely job. With that in kind of serverless world, it doesn't really work because you haven't got an application, right? You've got a series of individual functions that when deployed to, let's say, Amazon and joined up to API Gateway, form a service, but you haven't got something you can just run locally. So you can't just fire traffic at something locally because there is nothing to fire it at. So this core youth can't think, okay, how do we do this? So what Amazon suggests, and what we tried and actually worked pretty well, is it sounds a bit counterintuitive, but basically each developer has their own little sandbox area in Amazon that they can deploy to. So they just run a local script, and it basically takes their functions and deploys them as it would in your kind of CI world, but deploys them into their own sandbox area. And then you fire the traffic at that. So you basically deploy the app to the cloud every time. And you think, oh, that sounds like that's going to have quite a long feedback loop and be slow. But actually, your functions are super quick to deploy, and they're really small. And so actually, the feedback loop was no worse than lots of other places I've worked on, where to start the app up took a bit of time locally. And the great thing is, you're actually in doing that, you'll be reusing exactly the same deployment scripts that you're using to deploy your service actually properly. So you're exercising those all the time and getting feedback on whether they work as well. So actually, it's not too bad. So you just have to kind of bear in mind, you have to kind of just move your testing closer to production-like environments, and that's fine. There are examples people have provided to kind of mimic some local testing for this stuff, but they're all tricks in some way. There's not a real way of deploying this locally. So we tested in the cloud, and that was fine. You just automate it like normal. So security. So it's a bit of a dull one, but there are a lot of good wins here in terms of security. And another way, this is another one maybe for using as a lever to start to try this stuff out. And there's a good story from our client that I'll get onto. That was the reason we started using this stuff in the first place. So firstly, you haven't got any servers, right? So you haven't got any servers that are missing security patches. Because as we found out recently, that happens, right? So you don't have to worry about that stuff. Amazon are going to be probably better at patching servers than you are. So let them do it. You've got a smaller attack surface area, because if I can't log into my server, I don't have any credentials to. It's much harder for a bad actor to try and do that as well, because they have no credentials to steal, really. There's no SSH keys. There's no users to escalate privilege for. That server only lives for a few milliseconds, so your attack window is much smaller. They can't just, at their leisure, try different ways to break into it, because it'll be there, then it'll be gone, and then it might appear somewhere else, probably a different IP address, who cares? So it's much harder to get in. I've seen some scary videos of people that have managed to hack into Lambda stuff, but that is doing some really impressive stuff. So for your kind of normal, kind of bog standard ways of trying to infiltrate servers and so on, you're kind of exempt from quite a lot of that. An interesting one is there are no human sysadmins. And often we know that in our systems, it's the humans which are the point of weakness with phishing attacks and so on and so on. So there are no human sysadmins of these servers. So that kind of potential vulnerability has gone away. You don't have to mess around with firewalls and ports and things like that as well. And we're going to mess that up. The reason we used serverless at the previous client was actually our team landed a couple of months after some other teams did, and they built some software and they were trying to get it deployed. And this client was making their way in the world of cloud, and were just kind of on that migration path. But all their processes were kind of back in the old world. So people were trying to deploy these systems and having to fill in big forms about the servers they wanted to deploy. Have you installed antivirus on this server? What is the IP address and all that? And a lot of it was just, how do I answer this? Because it changes. I don't care. I don't need antivirus. But they were having to go through all these big forms. And so we were like, well, hang on. We don't really want to have to do this. Can we just say, well, let's try this Lambda stuff? And so all the answers about all the questions that say, does your server have? Which is about no server, not applicable, move on. And I'm being slightly glib about it, but when we actually sat down with their security folks and talked through this, they did concede that indeed a lot of the vulnerabilities are gone, and we could try it out and we'd monitor it, and that's what we did, and it stuck. So that was the reason we did it. It was partly we didn't want to have to go through security form-filling hell, and we wanted to get something out there basically and not be held up with other stuff. So what other things? The file system is actually read-only. So it's very hard. Lots of attack vectors disappear there. It's still worth pointing out that it's not like you suddenly don't have any credentials to manage. I mean, you are having to connect to Amazon or however, in some ways, you've got access keys, security keys. You're going to have to manage them. Good practices still apply. Stuff like don't check them into source control, etc., etc. You will always have keys. The way that Lambda works, for those of you who've done AWS before, is using the IAM IAM rules, basically saying what permissions and what something or someone is allowed to do in Amazon, i.e. I'm allowed to drop this role, gives you permission to put files in this specific S3 bucket, read data from any DynamoDB tables that begin with this. You've got all these whole kind of roles and you put them together and you only have permissions to do those things, with the idea being that if whatever gets compromised, it can only still do those things, and so your blast radius is reduced. And the same applies to Lambda, so when you create a Lambda, you assign it a role and it can only do the stuff in that role. So in the videos I've seen when people were doing malicious things, pretty much all of the malicious things with Lambda relied upon people misconfiguring the IAM roles and giving a Lambda too much permissions, because you're just like, oh, oh, it needs to get that file from S3. Well, I'll just give it the blanket anything in S3, in any S3 bucket permission, because it gets it working. You forget about it, you move on, and suddenly some quite important data has landed in another S3 bucket. That can see it. If it gets compromised, suddenly you can see that. There's no need for it to be able to see that. So keep your roles tight, and that applies just across Amazon in general, but Lambda as well. Fine. Operability, so fine, yep, cool, you can build stuff, deploy it, it works really quickly, it's cheap, but what's it like to actually run these systems? Because we need to keep our software running. The answer is, out of the box, it's pretty good. You get a lot, like for free. You need to customize some stuff, but it gets you quite a long way compared to kind of your own custom system. So logging is one. So if you remember back to those examples, in the JavaScript one, the first line was like a console.log statement, which in JavaScript is just right, that's the standard way to log something. And in the .NET one, I think it's like system.println or whatever the thing is in .NET to print something out, just the bog standard ways. And what Lambda does is it will take those, whatever you log, and put it in CloudWatch for you. So that's pretty cool, because if you think normally, for those of us, we all build systems and we all log stuff, but then we can't go spelunking through text files on servers, right? We need to have some kind of log aggregation in place so we can read them in a simple way. So we use things like Logstash or whatever to pick up the log files, parse them, move them into, Elasticsearch, whatever, or we use Splunk or something like that. But we have to have systems that shift files around and things like that. Yep, there are nice ways of doing it and nice tools available, but again, those are still tools that you have to maintain and extra code that you have to maintain that isn't really like, unless your company probably doesn't make money from log aggregation. That's something you need to do to keep your world moving, to allow you to actually deliver the functionality that is making your company money. You don't make money for log aggregation. So having a console.log line immediately arrive in a system that will retain it and display it to you and allow you to search for it is pretty big deal. You've cut out quite a lot of functionality normally there that you'd have to take control of. So this is fine, dumps them into a log stream, but we found after a while it was a bit annoying because each log stream is separated and we wanted an aggregated view because functions would be called kind of at the same time. We want to see how how our system flows through different functions. So what we did is actually, and this is what Amazon suggests, we used another Lambda function. This is kind of a common use case. We attached the Lambda function to CloudWatch and said, hey, please fire this Lambda function when a new log message arrives. And what that Lambda function did was pick up the log message and post it into an Elasticsearch cluster that we could have Kibana sitting on top of, and then we had nice searching and a nice aggregated log view that we're used to. But CloudWatch was the source of the logs and the kind of first staging post. And it's a good source of Lambda. It only needed to run when logs arrived, and it would just process them as it needed to. And that was fine. So this got us some of the way, but we felt after a while we wanted an aggregated system. So that was what we suggested. And Amazon actually provide you that function they write for you because the CloudWatch to Elasticsearch thing is such a familiar workflow. They actually give you the code to do it. So that's pretty cool. So monitoring. So logs is one thing, but we need to see at a glance how our service is performing. So this is basically a screenshot of our monitoring dashboard. So what we got here, top left, we have our writer Lambda. So that's our producer. And that graph is showing the duration of how long it took to run, invocations, errors, and any throttling that's happening. This is our API gateway, so our kind of where our HTTP traffic's landing. This has got a number of requests, how many returning 4 errors in the 400 range, any in the 500 error range. And bottom one is the same API gateway, it's just showing latency of processing a request. So this stuff is all pretty useful, but you get like this all for free. Like this is either a small little bit of configuration or a few clicks in CloudWatch, and you get these graphs. Whereas again, systems I've worked in the past, there are lots of lovely tools out there like Graphite and so on for doing monitoring, and there's loads and loads, but you still have to wire them in and get the data from A to B and set it up, whereas it's just kind of here. And so out the box, this is pretty good to get you going because you need to know how your system is performing, because even though there has a lot of good properties to Lambda and things like that, so your functions will still take a lot of time if you're asking them to do a lot of work, and they will still return 400 errors if you're doing something wrong, or 500 if you're blowing up internally. You still didn't know about this stuff. There's no such thing as a kind of perfect system. So what we found, this was good. After a bit of time, it wasn't quite good enough. Like, for example, this only allows you to do things in the 500 error range if you wanted to know about specific error codes and things like that. You'd have to add some custom metrics, which is pretty easy, and I won't go into that. And also, you'd want to add maybe some business-focused metrics. These are all technical ones. You know, if your system processes, I don't know, transactions, you probably want to know how many transactions it's processing, but it has custom metrics that you can feed into. But out the box, again, you get quite a lot for free. It's pretty good. So deployments, what are they like? How does that work? So pretty simple, really. So you've got your functions, and basically you bundle your functions up into some kind of package format, and that package format differs based on what runtime you've chosen. So for the Node.js stuff, it's just a zip file. For Java, it's a jar, it's a NuGet package for .NET, whatever. And you just bundle it up into that, so that means you can take advantage of all the tooling that you use already. And then you basically hit an API endpoint in AWS that say, hey, here's my zip file and my code and a bit of metadata, like what do I want to call my function, how much memory does it need, and here's the triggers that trigger it, and they'll create it, and you're all good. So deployments are really quick because, for a start, your files are pretty small. You're talking normally a couple of meg or whatever. I didn't call it out explicitly, but you can totally use third-party packages. You know, those examples I gave are really noddy, but you can totally use other NPM packages and pull them in, and you just bundle those up the same. So you can have all your dependencies, and you just have to make sure you include them in your deployable thing. It's all good. But they're still going to be pretty small because you've got smaller units in general. So packages go up, and Amazon sorts them out. Another nice property is that the deployments are 0 downtime by default, which is just a nice side effect. So again, how many systems have you worked on where it needs to be up all the time, or you as a dev don't want to do out-of-hours deployments, and so you've had to put some engineering effort into making it so that you could deploy new versions whilst keeping the system up, so maybe doing blue-green deployments or things like that. That, again, is extra complexity, but with this, you give it your new function. Any current functions that are in flight will just run to completion, and the next one that picks up will just pick up the new version. So that'll all run quite nice, so it's a nice kind of side effect. What we found worked for us, you could deploy each function independently, but that's going to get pretty crazy, especially if you're doing continuous delivery and you have pipelines. You have like a pipeline for function. That would go insane pretty fast. So what we did is we kind of bundled our functions up into services, which, if you remember from the architecture, we kind of had these nominal services that were collections of functions, and they would always get deployed together. So there'd be like 4 or 5 functions that would always go together, and that was fine. Even if they weren't interconnected and didn't call each other, we can still consider it a system, and that worked for us. And if one got too big, just chunk it up, kind of microservices way or whatever. So that seemed to work for us, and so we had a deployment pipeline for each service. Normal good practices apply with that stuff. Just package up your deployment artifact and move it through stages of a pipeline to different environments. We just had nominal QA and a pre-prod environment, I think, which is just collections of services in different AWS accounts. But yeah, the package was the same thing that moved through. And it's worth calling out that, again, these Lambda functions don't live in isolation. Typically, you're deploying other services as well in the cloud, whatever it is, your S3 buckets. Apply the good conventions to those, like infrastructure as code and not just clicking around in the console and so on. And all your alerting and the logging and all that setup that I kind of showed, again, bake that into your code is what we did. And so we kind of had the rules for alerting and dashboards sitting alongside the code for the service, so it all lived in one place, and you could just make a change and it would get pushed out. So yeah, good practices like that still apply. Just think, could you automatically create a new environment if you needed to? If the answer is yes, you're probably doing this stuff well. So there's a bunch of around, so all the cloud provider offerings are growing and loads of stuff is happening. And around that, there's this ecosystem of open source stuff which is happening, which is good. That's a good sign of a healthy area, and it's great for us developers. So this is an example of some of them. Probably the most popular is this one, helpfully also called serverless, which makes things confusing. But in their defense, they have a lovely, like, I don't know if you can see it, lovely animated, like, burning GIF with an S. So you can't complain about that. So what these do in general is give you some kind of like opinionated tooling around the edges of deploying and testing pretty much your functions as a service. So they basically say, hey, if you write your functions and put them in this kind of hierarchy So have a folder here with the name of your function, and you drop a JSON file with some config in at this level, and you write your function here. And then most of these, I think, are just NPM packages or something. But then you run this command line. They basically give you some command line tools. Run this command line. We'll take the job of spidering through your hierarchy of files and taking that and deploying them to AWS functions. So they'll handle that deployment bit for you. And calling the right AWS APIs and so on. And that's pretty handy. So for getting up and running quickly, for proof of concepts, these are great, and I would totally advise using them. We didn't. Part of the reason why is that this was earlier on, and these were still quite immature and changing quite a lot, and we didn't want to end up hitching our cart to the wrong horse. And so we looked at what they were doing, and we just said, no, you know what, we're going to write our own little scripts and just call the AWS APIs ourselves, which wasn't that much effort, but it would have been quicker to use one of these, but we didn't want to box ourselves in. So we just did our own stuff. And I think at the time also none of these had offered a kind of idempotent way of deploying. It always had the notion of create my function or update it. And we wanted our pipelines to just be able to create or update regardless of what was there before. So we had to kind of build that into our scripts. But that was fine, yeah. If you want to start messing around, totally start with one of these. I think serverless is a good one to do. Cloud is interesting. It has a really nice use case where you can write a node application in Express, and it will kind of disassemble it for you and reassemble it as using API Gateway and Lambda. So you can just kind of write it in a framework and a language you're familiar with, but you get all the advantages of the serverless stuff as well. So that's quite a nice way of getting started. So I won't touch on those anymore, but they exist, and definitely go and check them out. So this is what we found is the pit of success. So for those of you who don't know the saying, I bumped into a few people who asked me afterwards what it means. So the pit of success is in stark contrast to a summit, a peak, or a journey across a desert to find victory through many trials and surprises. We want our customers to simply fall into winning practices by using our platforms and frameworks. So that was a program manager at Microsoft. But basically, we want people to succeed by accident, basically. You can't help but succeed. So AWS Lambda tries to help you do that by kind of imposing limits on you. So I mentioned a few. So there are limits like how long your function can run for. I think it's 5 minutes. There are limits on data sizes. I can't remember what it is. It might be here. Something like 128 meg or something like that. They change it. You have a certain memory limit. You can go up to 1.5 gig for actually memory that you make use of using it. So some of these are relatively small, but they're trying to force you to think small. These aren't meant for big batch processing jobs. And these are hard limits. Like if your function goes over 5 minutes, it will kill it. So yeah, so you have to bear that in mind. So we ran into issues with this because our system, we'd be happily going along, and then things would just fail hard, and we'd be like, and then we're like, oh yeah, no, it totally did say that. We just kind of skipped over that. But yes, we're running in 5 minutes. Right, frantically re-engineer, put something in place, chunk things up. So that's why we ended up with queues in place, and we ended up splitting requests and zipping and g-zipping things and so on. And what we ended up with was, yes, a better architecture, probably, but we couldn't make those changes at our own pace because things kind of broke hard. So don't make those mistakes. Look ahead and look what the limits are. They're not ridiculous limits, but there are limits there nonetheless. But the trade-off you make is Amazon is saying to you, hey, if you play by these rules, we can offer you these cool features like the scalable by default stuff. So it kind of goes both ways. So worth pointing out, this is just, I'm not going to go through all these, but since May 2016, so we're basically a year ago now, these are some of the things that have been added. And like every month, Amazon and Azure or whatever add a whole load of new features. And these are all features I went through and basically said, if these had been in place at the time, would we have used them? And pretty much all of them, yes. So they're always adding useful stuff. I won't go into too much detail because some of them are kind of small, but things like dead letter queues are really cool. Really cool. Like Amazon want you to build real life systems. They know that your processing of your functions are going to fail at times, either through you or through something else. So they've introduced dead letter queues so that pops it. If something fails, you can have retry amounts. It fails after that many. It'll put it on a dead letter queue that you can examine either automatically or as a human and fix it. Things like that. Retention of metrics is great. Better visualizations, environment variables, new ways of deploying these functions, loads of good stuff, and it keeps going up and up and up. So this world is growing. So anyway, I've waffled on enough about that stuff. So you've seen some of the things we liked and didn't like. So should you bother using one? I've told you some good stuff, some bad stuff. Unfortunately, because I'm a consultant, I have to, I'm contractually obliged to say it depends. But I think the question I now ask myself when I'm looking at new systems is there a reason not to? Is there anything that will mean that this just would not succeed using serverless? Because I get so much out of the box and so much for free, it means I can get a lot further and actually validate whether the idea that we have is actually going to work. We all want to get to this kind of MVP or whatever. We want to get there as soon as possible. We want to see if we've got traction or if we're just wasting our time. And serverless totally helps with that. It moves you, a lot of the stuff you get out of the box, and it moves you a lot further towards a working system than in more traditional ways, in my opinion. And so it's totally worth trying to explore that first. But this is the advice for what to do if you think this sounds cool, but you don't want to just bolt straight in and start to rewrite the core of your application, which I don't think I would advise. So I realized I kind of wrote this advice out, but this applies to any new tech, right? You've heard there's this cool new thing. We want to use it, right? Well, how should you use it in a kind of sensible manner that won't bring down everything? No one wants to have that reputation as the person that always tries out new tech and breaks everything. So first is nibble at the edges. You've got a system. Pick off the bits around the edges that aren't mission critical but are still super useful or just annoying or sap time and mean that you can't be focusing on the real stuff. So what are some examples of some nibbling suggestions? So some of these we've seen already. Scheduled jobs. Lots of systems have these kind of cron jobs or whatever that run on a regular basis to do whatever. Maybe start to move those into functions as a service online. Log streaming, mentioned that. You need logs moving from A to B. Maybe start using them for that. Webhooks, maybe you've got some notifications that when a build fails or something happens in your system, you want to pop it in Slack or whatever your messaging tool of choice is. Functions as a service are perfect for that. Kind of these just short-lived endpoints that just need to do a bit of processing. Great for that. Chatbots, they're kind of becoming the rage. There's lots of frameworks that use Lambda to build chatbots and so on. And proof of concepts, again, just getting something off the ground quickly. This is great. You can get a long way without that much effort. This is the pit of despair, or the pit of success from earlier, depending on how one falls in. Don't just go diving in, abseil into it. So what I'm trying to get across by that is, so sure, you've used it around the edges of your system, these kind of serverless stuff. It looks good, you like it. You've got the hang of how you deploy it and how you work with it. You've done some kind of upskilling in your teams. So now you want to actually replace something a bit more critical to your system. Don't just jump in. So know how much traffic is going to be flowing through that function. You should have those stats anyway. Make sure you've got monitoring and logging in from the start. Again, you get some stuff for free, but it's not going to write log messages for you, right? So make sure you have useful logging, so hopefully semantic logs or something like that to give you useful feedback. Get your monitoring in place early on. Safely replace those existing systems. So either by doing things like dark launching it, where you're pushing traffic to it, but it's not actually live, so you can see how it handles it, or shoveling a certain percentage of your traffic off to it, things like that. Do it safely and have a backout plan. Be able to flip back to the old way of working at reasonably short notice if something's not right. Again, you could apply this to kind of any new system you want to roll out. So part of there's been some anger around this serverless stuff. A lot of it has been from the kind of infrastructure automation community, the kind of the DevOps world. And a lot of it's been this horrible hashtag, which is NoOps. I don't think it's Noops, I think it's NoOps, which is basically, hey, look, this does so much stuff for you for free, all this serverless things, we can just fire our operations teams because there's no servers to run anymore. So we can fire them, we can hire loads more devs, and we can get loads more done. Is that the case? So not from what we saw, no way. So you'll kind of need those operations skills and that operation mindset in your team more than you ever did. So sure, yep, you don't have server maintenance, and you don't have to do scaling, like configurations of auto-scaling and growing and contracting services under load. But that's just a small subset of what operations actually really is. You have to think about still all this other stuff, like log aggregation, monitoring, alerting, infrastructure as code, the continuous delivery, just because these things are easy to deploy, you've still got to have good practice about having pipelines and moving artifacts through pipelines. All that stuff can be considered under world operations. And to be honest, who cares what someone's title is? In your team, you need to be thinking about this stuff. And so you need that mindset. The world and the responsibilities of a developer is changing. The world of an operations person is changing. Some have just become one. This is just a continuation on that. So don't go firing all your operations folks. And the last thing to consider is, and this is quite a big one, and this is some of the reason you will get pushback on why to use this stuff. And I have no answer for you. But what's worth pointing out, so let's say you're going into the cloud. A lot of people go into the cloud. You are taking a dependency on your cloud provider. Like, you can't get away from that. Sure, you can mitigate it by going to multiple cloud providers. You are then having added complexity. There might be other reasons you want to do that for, failover and stuff like that. But you still have a dependency on that cloud provider. Fine. But let's say that you go to AWS and it doesn't work out. It's not too expensive, or your company, and this has happened before, I've seen it, gets bought by a company that is in direct competition to Amazon. They say, we can't be paying Amazon money. They are now a direct competitor. We can't use it. We need to go to something else. Fine, you can take your application, because it's still an application. So if you have a Node.js app, you can say, fine, that's a bit of a faff, but we'll take our Node.js application, we'll take it off Amazon, and we'll run it on Heroku or something else. And I guess this is one of the big wins of containers, because they are a portable format that can run pretty much anywhere. And so you're buying yourself that future flexibility to move around. And that's fine. So that makes sense. But with functions as a service, there is no standalone application, right? You're writing these functions, and they're pretty coupled to the definitions that the cloud provider says you have to provide. I couldn't take those functions that I showed earlier and run them out of the box on Azure or something like that. It would have a different setting, like kind of different interface. So sure, you could probably go to both with a different outer layer and some inner logic, the same, but quickly becomes quite complicated. It's not like you're writing your code in a proprietary language, so you can still port it across as long as that language and runtime works somewhere else, and it probably will. But you've still got that coupling of function definition to the cloud provider. And kind of there's a third level. If you go with one of those frameworks that we looked at earlier, so serverless or whatever, you're coupled to that as well. So sure, it might be great at the minute, but they might start to go off in a direction that doesn't work for you, and then you've got no way of deploying independently based on that, because they've got their own way of how you lay out your code and so on. So that's the same as coupling to any other framework and so on, but it's just worth bearing in mind. So you're a few levels deeper than you might be normally. And it is what it is, right? There's no way around it really, apart from go into it with your eyes open and know that you're taking on that coupling, and maybe you can consider it debt. You're making a bet, I guess, and you should maybe do some proof of concepts first, do some spikes to see if this is actually going to work for you and it's going to be worth the trade-off. I mean, Amazon aren't going anywhere, so you're probably going to be fine, but it is worth calling out you have got this coupling. What was that?
Why to raise the prices?
Yeah, absolutely. You're totally right. I mean, at the minute we're in this kind of golden age where all the cloud providers are competing against each other, and so their prices are staying, especially for the serverless stuff, really super competitive. But you're totally right. There's nothing to stop them. If they bump up, then, or even I've seen systems where the pricing goes up where the way that you're being billed just changes slightly, and just happens to be that the kind of niche way you're using those services that was working out great for you before now does not work out. So even though 90% of customers are cheaper, it's not for you because of your use case. So yeah, but of course prices could go up, but it's very hard to compare. It's not comparing apples with apples if you take this stuff in-house or whatever. There's all the other. It's not that you compare the hosting costs directly. Let's say you're talking about serverless. A lot of it is the cost savings you're making, not just in the bills that are coming from Amazon, but the cost savings you're making in not doing all that other work. And that is dev time, that is code maintenance, that is bugs you will write in all that other code, systems that have to be kept up, all that kind of hidden cost. And also lost opportunity cost of not doing the work that actually delivers the value to the customers and makes you money. Versus doing all the kind of infrastructure bits that are quite fun, but really don't offer value to the end user. So all that stuff. Anyway, this talk isn't about that. But anyway, we're kind of at the end. So we talked about what is a serverless architecture, went through a kind of big, long definition. We had looked at some diagrams, but then we dug into functions as a service and the properties of them, the statelessness, ephemeral, triggered by events, and so on. We looked at a sample system, Tales from a World Without Servers, looked at some stuff that we liked. We liked a lot of things about it. We liked the fact it scaled really well. We liked the fact it got us up and running quickly, and we got our system out the door before the other teams and in front of users, and we could iterate on it from there, which was a big win. All this stuff really helps with continuous delivery, really, really helps. We really like the cost. The people paying the bills really like the cost. The serverless component of this, when we did the costings, was so cheap compared to the other things, data storage and so on, which they were going to have to pay for anyway. So it was orders of magnitude cheaper, so they really liked that. And we would just pay as we scaled, which was great. And then we looked at, should I use one? So I gave a bit of a comical answer, and it depends, but I started to ask the question, should you not? And what happens if you don't use a serverless architecture and your competitors do? Like, what is that edge they are gaining or not gaining? Think of it like that, and that's often a way to kind of another lever to use to get in. So, and we looked at some tips for kind of migrating a system across and getting started with this. So if you want some more reading, there's an article on Martin Fowler's website on serverless by a colleague of mine called Badri Janakiraman. I think I've done well to get through about 45 minutes. I've only just mentioned Martin Fowler, and I work for ThoughtWorks, so that's good. That's well, but I have to mention him once, I think. And there's another article on him by a chap called Mike Roberts that goes into more detail about serverless and some other use cases. But the one I really like, some of you might have read Simon Wardley's stuff. I love his stuff, and a lot of it goes over my head, but this I totally agree with. And he is like, he's basically saying the opinions that I'm not quite brave enough to say yet. And his take is basically that this is going to change the way we write software. There's some quotes from it. He's basically saying that serverless will fundamentally change how we build businesses around technology and how you code, and that containers aren't really that. They say they're important, but ultimately invisible subsystems, and this is not what you should be focused on. I mean, actually, under the covers, Lambda runs on containers, but I don't care. It just runs my function. And he's saying you thought DevOps was big, but it's chicken feed compared to this. This is where the action will be. This is where it'll be with you quicker than you realize. And now's not the time to be building a DevOps team and doing infrastructure as a service. That boat's sailed. That's gone. You need to, I think you use the term, skate to where the puck is going and go on this, because it's all about building on the capabilities of other people and then adding your value on top, not getting snarled up doing work that isn't core to your business. So yes, definitely, if you read one thing afterwards, read this. That's it. Thank you for coming. Cheers.